Next, we're going to discuss at a higher level on data warehouse design and usage. We mentioned that data warehouse is a very complex piece of a software project. It covers the entire enterprise, the data and the processes to support decision making. Therefore, to prepare for a data warehouse is a very challenging task. It should be very carefully done. And there are 4 views involved when we looking at the design of a data warehouse. We have, so all views need to be applied concurrently. Every view give us some good information in terms how this data warehouse need to be designed, what the final product going to look like. So the top-down view is somebody with a thorough understanding of this enterprise, this organization that we designed the data warehouse for. It totally understand how the business work and what kind of decision making is needed. Having this view allow us to select the relevant information necessary to be included in the data warehouse. So this is maybe companies' CEOs, main players who really knows every aspect of this business everyday operation, and maybe also future plans. And the second view is the data source view, that we need to understand what data sources are available, what data sources contribute to the decision-making processes. And we need to expose those information that to be captured, stored, and managed by the operational systems, and then decide how to select and understand each piece of information, what their functions are, what kind of decision support they provide. The data warehouse view, having understanding the top level understandings of those the first 2 views, we can start to think about what are the facts, what are the dimensions. And then we will select what maybe, depending on the size of the data and complexity of the data, deciding what data schemas that we want to choose to organize the data. And lastly, business query view. This is the view from the end users, the knowledge workers who's going to use this data warehouse to answer certain questions they have in order to make decisions. So here, once you have data organized, do you actually support variety of the queries that the user need to use in an efficient and effective way, and how to represent the data in an intuitive way that the user can understand. So all 4 views need to all play a critical role in the design and the planning process. So we talked about planning. The planning should define the scope and the goals. The goals need to be specific, achievable, and measurable, so we know if we have achieved the goal. Without very specific planning, a data warehouse can linger years. A data warehouse project can linger years and years and years and years. The requirement study that we mentioned earlier, problem analysis, and then come down to warehouse design, data integration and testing, deployment of the data warehouse. That's the final step. We organized those steps in a very logical way, but those steps often are not cannot be executed in this nice clean fashion. We often have to go back and do lots of different iterations um, to actually moving towards the correct direction, try to achieve our goals, and constantly measure our progress. But it's not going to be a straightforward process because a lot of times nobody really knows every detail of the business, and the users expectation of the systems often change, and users don't often don't have a very clear idea, that they cannot give you a complete specification in terms of what they want. When they say A, that's going to remind them that I also want B. So this is a process. So in the design, so here we talk about the design, warehouse design. After everything has been done here, the previous step, that we have a fairly clear, we have a fairly clear idea that what need to be included in the warehouse. And now we need to design the warehouse. So the warehouse design process is very similar to design of any complex system. You can take a top-down or a bottom-up approach. A lot of times you'd actually combine both. A top-down approach is makes sense only when you actually have a very clear, very clear plan. That the enterprise itself is very mature. Its operation are sort of standardized. That you might have an earlier version of data warehouse that the system, that the users already know where need to be improved, and what are the issues. And in those cases, you can take a pure top-down approach, start with the overall design, and start to implement those. Most of times you don't actually have all those information. So you will take a bottom-up approach. You will start with some units, gather some information, and based on the information to design and ask questions, what functionality I need, what queries are needed, and do lots of prototypes and do many iterations, using rapid prototypes to solicit new input from the user. The user, a knowledgeable person within the enterprise, can offer you a lot of information that you could actually use those information, and based on your analysis of the data collected, and took a combined approach to data warehouse design. The book also talk about the software engineer point of view, and the book mentioned waterfall and spiral. I personally consider those are all outdated. And the more effective approach to software engineer, especially for a complex software engineer project like a data warehouse, you probably want to choose the agile approach. Waterfall and spiral all have this assumption that the user can specify what they want. They will provide you a good specification. Waterfall assumes like, well, those are the steps. We follow the steps and we're going to get the perfect result, which never happens. So I think waterfall is pretty much abandoned in software engineer. Spiral considers the changes, so it has iterations. It's called Spiral because the software is designed in iterations. I will rapidly develop the first round and adding additional functionalities and getting user feedbacks. It works better than waterfall, but still it assumes that we just keep on improving what we know about what the user wants. that's still not the reality. The reality is the users don't actually know the 100 complete picture of what they want. So the agile approach does not assume that the user can provide you a complete specification for the software. So that agile use rapid prototyping and completely keep constant um, con contact with the end user and keep on modifying the specification. There are a whole set of methodologies that Angel use, like morning standing meetings. So every day that we have a meeting together and check our progress and gather feedback and see what need to be changed, so that you don't actually spend out months of time and produce something that user says, I'm not sure I want that. So the steps involved in data warehouse design is first to choose a data process to model. So that's the subject that we want to focus to for one component of the data warehouse, whether it's sales, customers, orders, invoice, and then we decide the granularity level that we want to work with. And then we want to determine what the dimension tables, what are the measures um, that that we want to include. So once we have the data warehouse designed and deployed, tested, there is strategies on testing and deploy as well that you can read more details in the book. How do we use a data warehouse? One is for information processing, support querying, basic statistical analysis, charts and graphs. This is supported in all data warehouse applications. This is often called basic business intelligence platforms. Online analytical processing, we have mentioned it many times. And also you can actually do data minings on a data warehouse application platform. So this brings us to the topic from online analytical processing OLAP to online analytical mining OLAM. Yeah, this chapter has lots of acronyms. So the reason that data cubes support online analytical mining is obviously because that we have aggregated clean data. That's the key advantage. Other advantages include the availability of OLAP platforms for connection to database, to access other utilities, and using OLAP tools to help us to navigate and understand and see, generate mining hypotheses to see what is worth exploring. Right, so you have this exploration tools to allow you to already review some of the patterns for you that you can further conduct deep mining tasks. You can OLAP environment or a business intelligence platform can also, many of them already have implemented typical mining algorithms that you can actually in one place select your data and the mining algorithms to perform efficient and effective mining tasks. So that concludes our high-level discussion on data warehouse design and use. Next, we're going to talk about some of the techniques used in data warehouse implementation.